There are an estimated 100 million black holes scattered across our galaxy. We have confirmed the existence of fewer than 100. Sit with that gap for a second. 100 million versus 100. That's not a small margin of error. That's almost the entire population, completely unaccounted for. Sitting somewhere out there, right now, giving off no light, no warning, no signal of any kind. And one of them, the closest one we've ever found, is 1,600 light-years away, which sounds distant until you realize the galaxy itself is 100,000 light-years wide. On that scale, 1,600 light-years isn't far at all. It's next door. It's called Gaia BH1, and for millions of years it sat there completely unnoticed. No telescope caught it, no warning system flagged it. It took one satellite, one oddly wobbling star, and 4 months of round-the-clock observation before anyone realized it was there at all. By the end of this, you'll understand exactly how something 10 times the mass of our Sun can hide in plain sight, and why the number of these things we haven't found should concern you a lot more than the one we have. Let's start with the number that should actually stick with you. Astronomers estimate our galaxy alone contains somewhere around 100 million black holes, the leftover remnants of billions of years of massive stars living fast and dying young. Now take a guess. Out of those 100 million, how many have astronomers actually confirmed? A small handful. That's the entire tally across the full history of astronomy. A number so small it barely registers as a fraction of the estimated total. Most of the black holes we have found were found the easy way, caught actively feeding on a nearby star, ripping material apart and heating it until it screamed out radiation bright enough to detect from across the galaxy. That method works, but it only catches black holes in the act of consuming something. It says nothing about the ones that fed long ago, went quiet, and settled into permanent silence. It says nothing about the ones that never had a companion star close enough to give them away in the first place. Which means the number we've confirmed isn't a real count of what's out there. It's a floor, a minimum. The true number sits somewhere between that small handful and 100 million. And right now, we have no reliable way to close that gap. So the question isn't really how many black holes exist. We already have a rough estimate for that. The real question is, where are the rest of them, and how close have they already gotten without us noticing? That question gets a lot less abstract once you understand exactly how close the nearest confirmed one actually is. Gaia BH1 sits about 1,600 light-years from Earth, in the constellation Ophiuchus. Say that number out loud, and it sounds safely far away. But stack it against the size of the galaxy, and it stops sounding distant at all. It's the astronomical equivalent of discovering someone's been living 2 houses down for years, completely unnoticed. Picture the night sky the way you normally see it. Familiar constellations, scattered points of light. Nothing menacing about any of it. Gaia BH1 sits in one of those perfectly ordinary-looking patches of sky. You could look directly at that region tonight and see absolutely nothing unusual. No glow, no shape, no warning. And that's exactly what makes it different from almost everything else out there. A comet has a tail you can track for months before it arrives. A solar flare builds for days before it erupts. Even most black holes typically announce themselves in some way, tearing apart nearby material, heating it until it glows in wavelengths our satellites can catch. Gaia BH1 does none of that. It isn't feeding, it isn't glowing. It's simply there, 10 times the mass of our Sun, compressed into a sphere you could walk across in under an hour, giving off absolutely nothing to prove it exists. If something that massive can sit that close without a single visible sign, what does that tell you about the ones we haven't found yet? Are they farther away? Or just better at hiding? So if Gaia BH1 gives off no light and no signal, how did anyone find it in the first place? By accident, more or less. It started with a single star, bright, stable, sun-like, nothing unusual about it at first glance. It was one of nearly 2 billion stars being tracked by a European satellite called Gaia, whose entire mission is mapping the precise position of stars across the galaxy. And this particular star kept doing something it shouldn't. Instead of moving in a smooth, predictable line, the way a lone star should, it was tracing a tiny repeating loop, a wobble, as if something invisible kept tugging it slightly off course. A team of astronomers didn't dismiss it as noise. They chased it. 6 telescopes, 39 separate observations, 4 straight months of watching that one star, ruling out explanation after explanation. Take a guess what was tugging on it. A planet? A faint companion star? The real answer surprised the scientists too. One by one, the ordinary explanations collapsed. Whatever was out there was too heavy to be a normal star, too massive to be a neutron star. Only one candidate remained, and it wasn't a comforting one. Something with roughly 10 times the mass of the sun, completely dark, quietly orbiting that star the entire time. They hadn't found a black hole by seeing it. They'd found it by catching it in the act of hiding. Here's what that discovery method actually reveals, once you think about it for more than a few seconds. Gaia BH1 was only found because it happened to have a well-behaved companion star nearby, one wobbling in just the right way, at just the right distance, for a satellite to notice. That's not a method, that's a lucky pairing. Which raises an uncomfortable follow-up. What about the black holes with no companion star at all? The ones drifting completely alone through the galaxy, with nothing nearby to wobble, nothing to give away their position. We have no method for finding those, none. They could be moving through our section of the galaxy this very year, and there would be no way to know. Not until, by pure chance, something got close enough to feel the pull. Astronomers believe these silent, companionless black holes may actually make up the majority of what's out there. Not the loud, feeding ones that light up our telescopes. The quiet ones. The ones doing exactly what Gaia BH1 did for millions of years before anyone noticed, sitting motionless in the dark, waiting for a coincidence that may never come. So where does the search go from here? Astronomers are now using the same wobble tracking method that caught Gaia BH1 to comb through the Gaia satellite's full catalog, nearly 2 billion stars, looking for any others showing that same telltale twitch in their motion. Every data release makes the measurements a little more precise. Every year, a few more candidates get flagged for follow-up, but the honest limitation remains the same. This method only works when a hidden black hole has the good fortune of a visible companion star nearby. For everyone discovered this way, there could be dozens more with no companion at all, quietly drifting, completely outside the reach of any current search method. Gaia BH1 wasn't found because scientists were looking for it specifically. It was found because one star happened to wobble in a way precise instruments could measure at a moment when someone happened to be watching closely enough to notice. We looked into an ordinary patch of sky and found something that had been hiding there for millions of years, 1,600 light years away. We still don't know what else is doing the exact same thing, closer than that, right now. If you had to guess, how many hidden black holes do you think are scattered across our galaxy waiting to be found? Drop your number in the comments. And if stories like this one pull you in, hit subscribe. There's a lot more hiding out there.